Hey guys, Mr. Wilson here. Today we're going to talk about surface areas of pyramids and cones. At the end of this video, you should be able to find the lateral area and surface area of a pyramid and a cone. Okay, a pyramid is a polyhedron where one face, the base, can be any polygon and the other faces, the lateral faces, are triangles. Okay, that meet at a common vertex. Okay, the altitude is the perpendicular segment from the vertex to the plane of the base. Okay, the slant height is the height of one of the lateral faces. And we use this cursive L to represent this measurement, the slant height. Okay, so we look at this net. Okay, we have this square base. All right. Now, when I draw in my height here, this height of this triangle, this is the slant height. Okay, it's the height of the lateral face. When we look at this figure as a three-dimensional object, which I'll try to do, okay, our altitude would be the line from inside this pyramid down to the middle. Okay, this is the altitude. Notice the altitude is not on the outside of the pyramid. Okay, altitude is inside the pyramid. Okay, so recall that the lateral area is the area of the figure without the bases. Okay, without the bases. In other words, the lateral area of a pyramid is the area of the triangles only. Triangles. Okay. In this problem, there are 4 of them. 1, 2, 3, 4. Okay. In this pyramid, we could show the lateral area by 1/2 base times slant height times 4. Okay, because they're triangles, so 1/2 base times height. We said our base was at B and our height was L, and so since they're all the same, we could do that same thing 4 times. Okay, rearranging this, we could see it as 1/2 4B times L. Just rearranging it so that we can see what I want you to see. And what I want you to notice is that 4B is just the perimeter. It's the perimeter of the base. So we could find the lateral area of a pyramid by saying 1/2, say lateral area of a pyramid is 1/2 the perimeter times the slant height. Okay. To find the surface area, we just have to include the area of the base. And so surface area is going to be 1/2 the perimeter of the base times the slant height, because that's the lateral area, plus the area of a base. Okay, so let's flip this over and work towards some examples. So the perimeter below is a square. Sorry, the pyramid below is a square pyramid. The altitude is 24 centimeters. Notice the altitude, slant height, and half the base form a right triangle. Okay, this altitude, this slant height, and half this base form a right triangle. Okay, we'll use that because we'll be able to use Pythagorean theorem to find missing lengths depending on what we have. Okay. Well, now we're going to find the lateral area of this figure. Remember, lateral area is 1/2 the perimeter times the slant height. Okay. Well, the perimeter of the base in this case will be 80. The slant height given to us is 26. And so we can find the lateral area by saying 1/2 80 times 26, which gives us 1,040 centimeters squared. And that'll be all the outsides. Okay, now when we're talking about the surface area, remember that means that now we're including not only the lateral area, but we're adding a base to it as well. So the area of the base, since it's a square pyramid, we can say 20 squared. 20 times 20 gives us 400. 400 plus our lateral area, which gives us 1,440 centimeters squared. All right. And that will be our surface area. Okay, with that example, you should be able to do number 1, do lateral area and surface area for me. Bring that in so as evidence of you not only doing the notes but paying attention. Let's look at number 2 together. The base is a regular hexagon. Okay, and so we want to find the lateral area and the surface area. Regular hexagon might be helpful for us to look at this a little bit closer. Okay. Notice that they gave us this measurement here as radical 3. Hopefully you remember that as the apothem, which will come into play when we're finding our area of this hexagon. But when we're finding our lateral area, we need the perimeter and the slant height. We don't have either right now. So this is where that altitude and half the base making a right triangle helps us out. Okay, because now we can use Pythagorean's theorem, because I know that this is radical 3, I know that this is 4, and I need to find my slant height. And so I can say, okay, 4 squared plus radical 3 squared equals our slant height. And so 16 plus 3 will equal the slant height, and that will be the slant height squared, and that will be 19. So we need to find out what the square root of 19 is, and that will be 4.358. Yeah. Okay, so I'm going to say 4.36 on 36 on screen, but I'm going to do my best to make sure that I keep this here. And actually, when I'm doing my formulas, I'll just say radical 19. Okay, so I don't have to mess anything else up. Okay, now the next thing I need to find, the next thing I'm going to have to find is I'm going to have to find the perimeter of the hexagon. Okay, hexagon, hopefully you remember that the central angle is 60, because we did 360 divided by 6. So this is a 30, 60, 90 triangle. And a 30, 60, 90 triangle, which I'm going to take out here, where we have this side is radical 3, the apothem. This is 30, this is 60. Okay, so now we can find out what these other sides are. If you remember, across from the 30-degree angle is x, across from the 90-degree angle is 2x, and across from the 60-degree angle is x radical 3. Well, we see that x radical 3 is radical 3. So that means x has to be 1. Okay. Now that helps because now we know that this value is 1. Okay, and that means that the side is 2. So we can find the perimeter. Okay, the perimeter of our hexagon then is 2 times 6, which is 12. Alright, and so now we have the information that we need in order to find the lateral area. Lateral area is 1/2 the perimeter, which is 12, times the slant height, which is radical 19. And that gives us 26 point, I'll just say 2 meters squared. or we can say 6 radical 19 meters squared. Okay. All right. Moving on to the surface area. Remember, surface area is lateral area plus the area of the base. We can find the area of the base by using 1/2 the apothem, which is radical 3, times the perimeter, which is 12. Okay, so that gives us 6 radical 3. That's the area of one base. And so 6 radical 3 plus that last answer gives us 36.5 meters squared, or if we were given or asked for an exact answer, we can do the lateral area plus the area of the base. Okay, so there we go. Alright, now cones are almost exactly the same as pyramids, except, just like cylinders to prisms, we know what their base is going to be. Good with that. Okay. So, cones are treated exactly the same as pyramids, except the base is a circle. Okay, and the lateral face is a sector of a circle. The formulas are almost the same. Okay, for lateral area, the sector, it actually takes up half a circle is what the side is. And so what we'll do is we could say it's going to be 1/2 the circumference 2 pi r, and then times that slant height. Okay, just like our prism. Okay, 1/2 the perimeter times the slant height. But in this case, we have 1/2 times 2. It's just I'll say redundant. 1/2 times 2 just gives us nothing. I mean, just gives us 1. So the lateral area will be pi RL. Okay, pi times the radius times the slant height. Okay, for the surface area, remember surface area is just the lateral area plus the area of the base. There's one base here, pi r squared. Okay, so last example, we want to find the lateral area and surface area of this cone in terms of pi. So lateral area is pi times the radius, which is 5, times the slant height, which is given to us as, well, I don't know if it's given to us. Let's find it. Okay, so this will create a right angle, so we'll use Pythagorean's theorem and say 5 squared plus 12 squared. It's 169, so the square root of 169 will give us that slant height, which is 13. Okay, so this is 13. And so the lateral area is 65 pi. The surface area will be the lateral area plus the area of the base. So we already know that the lateral area is 65 pi. The area of the base is pi r squared. Pi 5 squared. So 25 plus 65 gives us 90. So the surface area is 90 pi. Centimeters squared is what I should say for both of these. Okay, so we've talked about pyramids. We talked about cones here. Hopefully you see the similarities. Yeah, that's it. See ya.